Welcome to our lesson part 2 on solving equations. Now we've solved several examples in our part 1 video, and we even solved one that looked just like this, except we had the opposite equation. There you had t sub c in terms of t sub f. So in this situation, we have t sub f in terms of t sub c, and the question is asking us to solve for t sub c. So that would be find, T sub C, of course, represents the temperature in Celsius, um, and T sub F, the temperature in Fahrenheit degrees. And for this question, we need to solve for T sub C. Now, in the last video, I mentioned that if you have a denominator, it's usually a good idea to multiply both sides by whatever it is in the denominator, to clear out the denominator so you don't have to deal with fractions as you're solving your equation. So we could apply that technique here as well, but then I'm going to show you there's also another way, an easier way to solve this question. So let's go through the steps. If you decide to go with the first approach, that is multiplying both sides by 5, so you clear out all the denominators, all the fractions in your equation. So you would basically multiply both sides by 5, but you need to be careful. This side is multiplied by 5, but when you multiply this side by 5, because it's an addition, you have to multiply the entire quantity by 5. That means the 5 will have to be distributed to both of these quantities. So if we do that, on the right-hand side, you have 5 times 9/5 t sub c. So the 5's are going to cancel there. So you'll be left with 9 times t sub c. So if you multiply 5 times the first quantity, the 5's are going to cancel. And then don't forget also to multiply 5 times the second quantity. So if we do that, we're going to get the left-hand side is unchanged. 5 times t sub f equals 5 times 9/5 t sub c. Again, the 5's cancel there. You have 9 t sub c. And then 5 times 32, that's our 160. Once again, since we're trying to solve for t sub c, we couldn't really divide by 9 at the moment, right? Because it's a plus 160. First, we need to get rid of that 160 and get a single term that involves t sub c, so we can solve for that. So to get rid of the 160, we need to subtract both sides. We need to subtract 160 from both sides. So when we do that, we get 5 times t sub f minus 160 equals 9 times t sub c. Again, this one disappeared because when you subtract 160 from that side, that canceled. The plus 160 and minus 160 canceled. Okay, one last step left to finish the question. Since we're solving for t sub c, and we have 9 times t sub c over here, to solve for that variable, we need to divide both sides by 9. And again, divide both sides by 9. And that is going to give us the answer. So the 9's on the right-hand side canceled. If you divide that side by 9, the 9's cancel there. You divide the other side by 9, and that's the answer. But sometimes, if you check the answer with the answer in the back of the book, you might find that they don't leave it in that format. If you factor out a 5 from the top, you can also leave the answer as 5 times quantity t sub f minus 32 divided by 9, or maybe even as this 5 9's factored up front, you might also see the answer like this. Just know that all three of these answers are equivalent. Your professor may prefer one version over the other, but technically they're all equivalent answers. Now, I mentioned a shorter method to solve this example. How would you do that? Let's take a look at that approach also. So we have the same question as we began in the previous page. The question is again solve for t sub c, but this time instead of multiplying both sides by 5, we're first going to try to get rid of this plus 32 by subtracting 32 from both sides. So if you do that, subtract 32 from both sides, you'll have t sub f minus 32 equals, when you subtract the 32 from this side, the 32 disappears. So again, we subtracted 32 from this side, those canceled, subtracted 32 from that side, and basically that's what we have over here. So t sub f minus 32 equals 9/5 t sub c. Still, we're still not there yet. We're supposed to solve for t sub c. At this point, you could multiply both sides by 5. So let's multiply both sides by 5 here. And the whole quantity on the left-hand side need to be multiplied by 5. And the 5's on the right-hand side cancel. And if you clean up everything and rewrite this expression, we get 5 times quantity t sub f minus 32 equals 9 times t sub c. Now, do you see what we need to do to finish this problem? To solve for t sub c, since it's being multiplied by 9, just go ahead and divide both sides by that coefficient so that they cancel out and we can solve for the unknown. And again, if we rewrite that with the 9's being canceled, our final answer will be same as what we got previously, 5 times t sub f minus 32 over 9 equals t sub c. And just like we did in the previous page, we can factor out the 5 9's and leave the answer in this form as well. Okay, on to another example. And again, I would highly encourage you, anytime you're watching a math video, to pause the video and try to solve the problem on your own before you go through the solution on the screen. All right, so this is our example number 7. We did 1 through 5 in the first portion of the video, and 6 through 8 we're covering on the second portion. So this is our number 7. Force equals k times m sub 1 times m sub 2 over r squared. We're supposed to solve this for m sub 2. And this is a formula you might see in your physics classes. Basically, the force of attraction between two bodies of mass 1, mass 2 that are separated by a distance of r. But you don't have to worry about it, what it represents for this particular example. Just look at it as an equation. You have a formula, an equation that has several variables. We're trying to solve it for one of those variables. So treat everything else as a constant. So how would you begin this question? If you said multiply both sides by r squared, you're on the right track. That would be a very good way to begin this problem. So multiply both sides by r squared. So we get rid of the denominator right away. And again, we're trying to solve for m sub 2. So we will need to isolate that quantity by itself. But first, the cleaned up version of the previous line. F times r squared equals k times m sub 1 times m sub 2. And since we're solving for m sub 2, all of this has to be gotten rid of. And since these are being multiplied by m sub 2, we can therefore divide both sides by that quantity. So divide both sides by k times m sub 1 on both sides. So these can be canceled. And our answer is m sub 2 equals f times r squared divided by k times m sub 1. Okay, and the last example is something you might see in your chemistry classes when you're covering the gas laws. So here, we're just going to take it for granted that this formula is given to us, and that we're also given some data that pressure 1 equals 1 atmosphere, volume 1 equals 15 liters, temperature 1 is 273 degrees, 273 kelvins, and so forth. So we're given also information about P sub 2, T sub 2. The unknown is V sub 2. So given this formula, can we solve for V sub 2? So for this question, we're going to plug in everything that we know. So plug in 1 for P sub 1, 15 for V sub 1, 273 for T sub 1, and do the same for the right-hand side. Plug in what we already know. So we should get an equation in only one unknown, which will be V sub 2. So when I plug in all those given values into the equation, this is what I got. Again, the only unknown is V sub 2, and we need to isolate it by itself. Since you have a single fraction on the left-hand side and a single fraction on the right-hand side, you could apply that technique we discussed in the previous video, which was the cross multiply method, and which simply states that if you multiply these two, that product must be equal to the product of these two. So let's write that out. So 1.0 times 15.0 times 373 equals this quantity, 2.5 times V2 multiplied by 273. And finally, to solve this equation for V sub 2, what would you do? Indeed, divide both sides by this product. Divide both sides by 273 times 2.5. Since those are being multiplied by V sub 2, to get rid of those, we're going to divide everything by that product. So on the right-hand side, they're going to cancel. We have what we needed, which is V sub 2. And on the left-hand side, we have the answer to this question. Now, when you're entering this into the calculator, you need to be extra careful. If you have several quantities being multiplied in the numerator and several being multiplied in the denominator, even when we do them separately and then divide it at the end, or if you're familiar with using parentheses in your particular calculators, you may need to enter parentheses before you enter your denominator as a product. So put that in a set of parentheses so that your final answer will be correct. And if we do all of that, and considering that we're also, if you are familiar with significant units at this point, also try to use the necessary significant figures to complete this calculation. Then your final answer should be 8.2 liters. And again, everything was given in consistent units, so volume was in liters. So we find our final answer has units in liters. And also, how many significant figures do we keep here? Well, with multiplication and division problems, you go with the smallest number of significant figures. And here, the smallest number of significant figures is 2 due to this quantity and this quantity here. So we rounded our answer to 2 significant figures here. So that wraps up our session on solving equations. So I hope this was a beneficial review for you guys.